You are listening to Tech Nuggets and Thoughts podcast, the show that focuses on principles and practices of coding and some interesting trivia around technology. We discuss all those things that a developer needs to know to craft better software. Listen to Nikhil, Christian, Siddesh, Mandar talk about their experiences and learning, which will make you a better developer.
Welcome to the 5th episode of Tech Nuggets and Thoughts. We shall continue the discussion from previous episode on testing.
So you said that unit tests should be fast.
Yes.
But you also said that unit tests make you fast.
Exactly.
Could you elaborate on that?
So why do unit tests, if they are fast, make us fast? When I make a change, as I said, there are two types of changes. Changes to behavior and changes to structure. When I want a change in behavior, I should first write a test that demands that new behavior, so that once I have implemented that behavior, I have the confidence from a passing test that I implemented that behavior correctly. And whenever I change structure, I want that I only change structure and did not change behavior by accident. So I run my unit tests as regression tests. Ideally, I can run all tests as regression tests. But the idea is that I just make a change to the structure, run my tests, see that they still pass, and have confidence that my change to structure did not break anything. That gives me courage to refactor. Whereas if my tests would take hours to run, then how often would I run them? It also gives us a new level of isolation. In the past, we thought we should have unit tests which are as fine-grained as possible, because when we run these tests, we want that we know what breaks. But when you have tests that are fast, you get the same level of isolation, not by the feedback of the unit test, but by your time slices, by your schedule, by running the tests every 3 minutes or something like that. Every time you make a change, you run the tests. You make a change, you run the tests. You make a change, oh, the tests fail now. You know what broke the test. It was your last change. You don't have to think much about what broke it.
Just the question, was it driven from the idea that usually when we talk to developers and tell them that you have to write tests and that they will make you fast, the argument is that, but I'm writing a lot more lines of code in the form of tests, and that actually slows me down and it will take me longer to write it. Is that?
Yeah.
Okay. So the other way I think of it usually is that tests will not make you fast for one iteration. Tests will make you fast when you consider multiple iterations, because they in a way make refactoring very easy. They make going live or delivering to production make it very easy. They reduce the number of bugs and the cycles that we would otherwise go through when we are delivering. The lifetime of those cycles reduces, effectively making us fast.
There's also another thing how they make us fast. So if you, without diving deeper into unit testing, if you follow test-driven development, which means to me, you follow those 3 laws as laid out by Robert C. Martin. The first law, you're not allowed to write any production code unless you have written first a failing unit test. The second law, you're not allowed to write more of a unit test than is sufficient to fail, and not compiling is failing. And the third law being you're not allowed to write any more production code than is sufficient to fail and to pass the currently failing test. So if you follow those 3 laws, this puts you in a cycle which we call the red-green refactor cycle. Red, you write the failing test. Green, you make the test pass, and then you refactor if you can refactor anything. By the way, we also didn't define refactoring yet, so I quickly give you the definition. Refactoring means changing the structure of source code without changing the required behavior, which links it to tests. We said test is an executable specification of required behavior. So how do you know that your refactoring didn't break anything? Run the tests. So an interesting thing, if you follow that, is you end up with far better software design and architecture than if you write tests later. Why is it why does test-driven development have this effect?
Because the source code is quite decoupled, I would say.
Why does testing decouple source code? How does it do it?
If you're talking specifically about test-driven development, in that case you write the test and you have to write the production code in a way that it is accessible via test.
Because you are thinking of testing first, or maybe you're thinking of functionality first. You think of invoking the functionality in a way that is not tightly coupled with the rest of the functionality. So
Exactly.
So,
Exactly those mechanisms.
Yeah, but let's be clear about these are two different things, right? Test first development, or what it was called.
Yeah.
Test-driven development is different, and
Test first programming.
Test
first
first
programming
is
is
actually a set of principles that guide how test should be. So that first is actually an acronym.
That's yet another thing. There's test first and first for tests.
okay, so basically there was a test first thing where these three laws of TDD were not followed.
Exactly.
So
So
that-
when extreme programming was originally created or invented and discovered and put together by those people like Kent Beck and Ward Cunningham and Ron Jeffries, and then other people like Don Wells and Robert C. Martin and Laurie Williams. Oh, she's my goddess of pair programming. She's brilliant. When these people devised extreme programming, in the beginning it was just called test first programming, because they already understood the effect that it has if you write and specify and implement your tests before the production code. But then test-driven development came a bit later, first with a few set of not really rules, more like guidelines by Kent Beck in his book Test-Driven Development by Example, and then later by Robert C. Martin in his Object Mentor and Uncle Bob's blog articles.
So in terms of business, I would say that when you do something, when you develop a code using test-driven development, it is actually increasing the confidence of the developer, right? I mean, when he says that, okay, this is the amount of test and my code is working. So that is actually helping him improve his confidence. Now, having said that, the next question that comes into the mind is what exactly to test? So like testing the code the developers themselves have written, or testing the code that other developers have written, or what about the boundaries? What about the physical, logical boundaries? What about the contracts? And what about the legacy code?
Okay. What to test, that also depends a lot on your non-functional requirements, like security, for example, and safety. If I would develop a normal business application and I use third-party libraries like Spring from Pivotal and the JDK, or I use the Go libraries from Google and so on, I would not test them. I would assume that third-party libraries work. Yeah, there's a rule from the book Pragmatic Programmer. It says select isn't broken. So whenever you encounter a problem, your first assumption should be that it's your own code that's at fault, not the library. Now we know that's not always the case. Yeah, sometimes it's really the third-party library that's broken. But first assume the library is working and the problem is in your code. When you're developing safety and security critical applications, your perspective on testing changes. Then you should not trust the third-party libraries, or maybe not even use third-party libraries.
There was one point in Clean Code book that was really interesting on this topic. Like, irrespective of the functionality of the software, what of the library that we do not fully understand how to use? So there was a concept of learning tests that we try out things to understand how to use this library better. Maybe we read through the library's code, maybe we read through documentation, we try out things. So the concept was that we should convert that into executable tests and let it be there in the application. That it does two things. One is it guarantees that someone else, we had the question, a developer had a question, some other developer has the same question, can always go back and refer to those learning tests to see how it is done, how it is invoked. And secondly, if ever we bump up the library version and the behavior or the execution way of that library changes, those are the first things that break. That clearly tells us that our assumptions of how the library worked changed, or is broken.
Yes, I like that idea, and I would combine it with what I said previously. The more critical your application, or the more critical your dependency on a particular library, paired with trust, or the absence of trust, should decide how much of this you do. For example, the JDK I would typically trust, whereas if I'm using a third-party library from a group of open source developers, I would have less trust. It doesn't mean that there are bad developers or that they are not trustworthy, but the amount of scrutiny that I can put into a product, not only by what organization delivers the product, but also about how many people are reviewing it indirectly by using it, decides on the level of trust.
That is what leads to heartbleed.
Yes. Very good example.
The assumption that the code is open and which means or implies that other people are using it, and which implies that other people are also testing it, has caused issues. And one of the examples is Heartbleed.
Yes.
So everyone just assumed one of the most important libraries, and we assumed that it was being tested.
Yeah. And these assumptions are not only about testing. These assumptions actually are partially also about culture. How many JavaScript developers do not know that messages should be sent to standard error because they use console.log, and console.log prints to standard out. Don't send messages via console.log. It's broken. Stop using it.
Yeah. We should generally use a logging framework and log errors to loggers.error. So.
Yeah, something like that. And I mean, the people are making wrong assumptions based on names. When Unix was created and these three standard file handles, standard in, standard out, standard error, were created, the only types of messages that people had on mind were error messages. And if you look at Unix philosophy, silence is golden. Normal Unix programs, they will not print messages unless there is an error.
Same applies. Same applies for the output of the unit test.
Exactly. Yeah. Silence is golden in general. I think it's a lovely rule, and it's often broken by Taylorist corporate dogma, which should not be applied in an agile software world. The rule silence is golden is a good rule, but it led to a wrong name. It's called standard error for standard error. It should actually have been called standard message for standard messages.
But just to make this clear, so when a test passes, you don't have to print anything. I mean, just a green indication is
use a framework.
Yeah.
And use the framework usually the way how it is configured out of the box.
Yeah. But
like don't try to generate management test reports from your JUnit runs.
But
Just trust green means pass.
Exactly. But on the contrary, when the test is failing, the test message should be very clear.
Yes.
So test message should be clear, and there should be only one reason for that message to come up.
Exactly.
Which means there should be
Single
only one assertion
single assert
in the test.
Yep. Exactly. It's a lovely rule. It shows how universal the Unix philosophy is. Because Unix philosophy says that everything should be doing one thing, it should do it well, and it should do it only. In architecture, we call this a single responsibility principle, and in testing, we call it the single assert rule.
Yeah. Probably you can relate it even.
Yes, so very much.
One person doing just one job and doing it well.
Correct.
So
So for that, job has to be defined very clearly in first place, which takes back to the requirement capturing.
I think we might have a little bit different opinions about that, because I think that for systems it should be applied, for people it should be slightly different.
I believe that there should not be even a single thing that is in the brain of a single person. I don't believe knowledge being stored in the brains of people. Brains are the most volatile storage medium ever.
So can I say that at this point, test cases are also helping me read my code in a better way at a later stage. Let's say I've given this project to one company and the product is like properly developed, it's deployed in the market, people are using it. Now I'm giving the same product to another company to make some enhancement for some whatever reason I have in my business calls maybe. And based on the test that you have written, that company would be able to understand the software in a much better way, and then I do not have to repeat my requirement again to that company. Can you say that?
Yeah, the test actually improves the readability of the code.
I have a thought. If we say that the first company is doing a really good job of writing tests and test statements, how likely would it be that you would have to move the vendor to a different company?
That's a very good point. But I think there might still be a situation.
I want to take maybe project in-house.
I mean, exactly. There are multiple situations where, despite me as a vendor doing an excellent job, my client may want to contract another vendor. It might also not necessarily involve me losing my contract. Yeah, it might be that the plan is I help that company to grow, and the company will then grow an in-house team. So there's a handover from one team to another. It might also be that the product is so successful that I now need more teams working on the same code base. So as a vendor, I still continue, but other vendors are onboarded and work on the same product. And in such a situation, whatever you've said before, that tests serve as a good documentation, is completely correct, but the tests become even more important the more people work on the same code base. Because then, how do you trust two developers doing a good job on a single product compared to how do you trust 200 developers doing a good job on a single code base and product?
We brought up the topic or the point of trust on the software or on the library multiple times. So what makes us trust a test?
I love that question. I want to see the test fail first before I see a pass. And that is the 3 laws of test development, yeah? The red-green refactor cycle.
Yeah, and even if you see that, okay, everything is good, just try sabotaging. Just try, making the production code, just comment out something and see if the test fails. And it fails for the right reason. So that is important. Even, I would suggest that if in case you see a bug, you find a bug, stop everything and write a test first and see if actually that test is finding the bug. Okay? Because if you write a test and it is passing, which means that you haven't found the bug. Once you have the right test, then go for resolving that bug.
Right.
So that's how it should be. For me, it's funny. It's not funny, but still, I relate it to question and answers. So it's just like when you have questions, it is easier for you to write the answer. I don't know how people just see the answer and then write a question about it.
Yeah, if you come up with an answer, and then the problem can be that you forget about the question. Just Google for 42.
Answer for everything. Life and everything.
Yeah.
Well, okay. To the same point, actually, there's a principle about writing tests that actually we brought it up before. The FIRST principle. It just is an acronym for fast, isolated, repeatable, self-validating, and timely or thorough.
You can just elaborate it. Okay.
Yeah. So we've talked a lot about the first point. The test must be fast.
We also have to talk about how to make it fast. That's one thing.
Yeah. So test small and test isolated. I think that
isolated, I think, is like the single assert rule, which is a single responsibility principle. So it should fail for only one reason. And that's connected to functionality and change and behavior.
Right. Sorry, I think I was trying to answer the question, but I kind of went into the next point. So what I was trying to get at is that I've seen tests where we actually reach out to an external database and validate
Third-party,
against it. So that makes the test very, very slow. I would rather spin it an in-memory database and test against it because that makes it very fast.
But what about mocking?
Oh, no mocking.
I follower of the Chicago school, no mocking if I can avoid it. So first of all, let's quickly talk about what actually is a mock. The more generic word is test double, which means that a real thing is replaced with a substitute, a double, for the sake of testing. And sometimes I use test doubles. For example, let's say I would write my own list class, which of course in Java there's no use case for that. But let's just, this hypothetical example, and then you will know that you have real use cases where this makes sense. I write a list class, so I have to store something in that list class. The object that I store, all they have to be is present. They don't have to do anything, then that's a dummy. If my objects have to do a little bit, like they have to differ, so I can actually say this list is configured to not allow duplicates. So how do I know duplicates? So these objects have to know how they differ from each other. Then we call them stubs. Then I want that these objects tell me how they've been used by my code. Then we call that a spy. And then when I want these objects to be so smart that they can tell me that they've been used correctly, then that is a real mock. And then besides those, there's also something we call fake. Fakes can also be so tremendously useful. Let's say you write code that has to talk to S3, and I want to test that code. S3 is not on your machine. S3 is not even in your building unless you work for Amazon. S3 is somewhere else on the planet. Talking to S3 is slow. Well, not saying that S3 is a slow product. It's a good product, it's a fast product. But from the perspective of unit testing, S3 is slow. Even if you're in Pune and your S3 is hosted in Mumbai, it's already gonna be a turnaround time of 50 milliseconds or something like that per request. And 50 milliseconds is a time in which I don't want to run a single test case. I want to run 100 or 200 test cases in 50 milliseconds. I need something faster. And then there's something called local S3. It's a Ruby library, but it doesn't matter that it's Ruby. You can still call it from Java. That you can just install in your project and you can just run this in your test and spin up something that behaves like S3. It's not the real S3, but it behaves like S3 locally on your machine. And then the turnaround time isn't 50 milliseconds, it's half a millisecond. Speeds up tests so tremendously.
Apart from speed, I have another reservation when reaching out to external third-party things. You don't control them. So you never know if they're up, if they're working the way they were supposed to work when you wrote the test. So I have kind of a reservation when reaching out to processes that are not part of, that are not under your control. That may be database, that may be another process running somewhere, even in your same stack. But I'd rather stub it out than reach out over the network to a different process.
Exactly. So basically third-party dependencies, not in the sense of libraries, but in the sense of runtime dependencies. They are good candidates for mocking and faking. There are more reasons for that even. I think that your test pyramid should be executable on your laptop offline. Imagine you're on an airplane flight from Delhi to Kochi. It takes like 2.5 hours or so. You're sitting there with your colleague and suddenly you have this brilliant idea and you want to work on it, and for that you want to refactor something and you can't run the tests. That would be such a pity. Make sure that you can run your tests locally. There's yet another reason for mocking and faking. That is the simulation of errors. If you want to build robust systems, you want to be able to simulate your system behavior according to your requirements in case a third-party service is down or misbehaving. How do you simulate that with the real thing? Not possible. You can't call Amazon, can you just make your S3 misbehave for a moment? I have to run this particular test. It just doesn't work.
Which means mocking is important. You cannot completely avoid it.
Yes,
but
absolutely.
There is a very niche use case where it applies.
But does that also mean that I can consider this mocking and faking for my own units separate, which are not part of my current development scope?
Yes, that's another very good point. So from our examples, you derived that very correctly. And that leads us to yet another point, that is, I can isolate parts of development and just discuss an interface with another team, for example, and say, you're implementing the implementation of the interface, I'm implementing the code that uses the interface, and I can write my code with the help of mocks without your code being ready for me. That's another use case. But for me, that is a temporary use case. I would like this mock to eventually go away unless this mock has good reasons to stay, which are from the list which we already discussed earlier.
Okay, so let's stop this episode here. We'll continue this discussion in the next episode. This is Nikhil signing out.
This is Christian signing out.
This is Siddesh signing out.
This is Mandar signing out.